Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Now we've come to chapter 3.2, Relative Extrema. So in this chapter, we will learn on three things. The first one is relative extrema. The second one is the first derivative test. And the third one, the second derivative test. So the usage of the first derivative test and the second derivative test is to further test whether the relative extrema that you have is relative maximum or it is relative minimum. So let me show you the overall of relative extrema. For example, you have this curve here, the blue curve. So first of all, you need to know that we need to find critical point. So I have written critical point as CP here. So what is a critical point? This is the point where the point will turn. For example, we can see the first point here. Initially, the point is going down. But at this point here, it stops for a while and it goes up. So you can see that the point turned. Therefore, this is a critical point. Other than that, we should know about stationary point. I have written here as SP. So what is a stationary point? This is a point where the point stops. So this point here is a critical point and it is also a stationary point because it turns, so it is a critical point, and it is stationary point because it stopped for a moment before it's going up again. And apart from that, this point here is the relative minimum because this point here is the lowest point that we have at this area here. How about this point here? This is also a critical point because your point turned from going up to going down, and this is also your stationary point. So this is a relative maximum because this is the highest point at this area here. Now let's see this point here. So this point is going down initially and then it turns a little bit. This is an inflection point and then it goes further downward. Okay, therefore this is a critical point because the point turns, and this is also a stationary point because the point stops for a while before it further going down. However, this is not a relative minimum or it's not a relative maximum. How about this point here? Okay, you can see that you have a sharp point here. So this is a critical point because your point turns from going down to going up. However, this is not a stationary point because the point doesn't stop here. It just goes down and bounce back up. Okay. However, this is relative minimum because this is the lowest point at this area here. Okay. So let's see, to find critical point, we need to see the slope. Okay, the slope is m. So how to find slope from your function fx? To find m, you just differentiate it once. Okay, so you can see that at all of the relative minimum and relative maximum, and this point as well, you can see that all of the slope here is equal to 0. So now let's see the notes here. We can get critical point when we find f prime x and equate it to 0. And then let's solve for x. So that point is your critical point. Okay, so when f prime x is equal to 0, the point is a critical point and is also a stationary point. However, we can find a point that is a critical point but not stationary point. So from the graph just now, this is the sharp curve. And we can also find it by calculation, which is f prime x. We just equate it to undefined. Okay, so when is your f prime is undefined, this is when your denominator is equal to 0. So I will show you the example after this. Please take note that we need to check the value of x, whether the value of x exists or not. So how to know whether the value of x exists? So first of all, we need to find out the domain of fx, and then we need to make sure that the point of x exists. It is within the domain.